Of our 7 parent functions, 2 of them aren't defined for all real numbers. They are the square root function and the reciprocal function. The square root function is only defined for values of x bigger than or equal to 0. So you would say that the domain is the set of real numbers bigger than or equal to 0. And the way to describe that, because it's a set, is with curly brackets, x such that x is greater than or equal to 0. Or you could do this in interval notation. You could write the interval from 0 to infinity. Same set of numbers. Now, I'll tend to, in my lessons, use interval notation rather than set notation. Over here, the reciprocal function is defined for all real numbers except x equals 0, so x doesn't equal 0. In set notation, we'd say all x such that x doesn't equal 0. Or, it's a little more cumbersome in interval notation, but you'd say from negative infinity to 0, union 0 to infinity. So the negative numbers or the positive numbers. So this would be the domain of our reciprocal function. Now we create new functions from our parent functions, and whenever we create functions from these two, the domain may be restricted. And so let's see some examples of that. For example, this function, the radical function, is only going to be defined when the inside function is greater than or equal to 0. So we will need 36 minus 3x to be greater than or equal to 0, which means 36 has to be greater than or equal to 3x, and divide both sides by 3. You get x is less than or equal to 12. And so the domain will be all the numbers from 12 to the left on the number line. Now this function is a rational function, which we'll study later. It's only going to be defined for real numbers other than 8 and negative 3, right? Because the denominator will be 0 there, so x doesn't equal 8 or negative 3. And this is a little cumbersome in interval notation, but you'd say from negative infinity to negative 3, negative 3 to 8, and 8 to infinity. So these 3 intervals. And finally, here we have a kind of a hybrid between radical functions and reciprocal function. Here, x plus 9 has to be greater than or equal to 0. So in order for this part of the function to be defined. So x is going to be greater than or equal to negative 9. And then for this part to be defined, we can't have x equal to 2. Now if I draw a little number line here, I'll put negative 9 right there, and I'll put 2 to the right. X greater than or equal to negative 9 refers to these numbers, right? Here and forward. But I have to avoid 2, so I have to put a little hole here. So let's just express this set in interval notation. We'd have the numbers between negative 9 and 2, so negative 9 to 2, not including 2, union the numbers from 2 to infinity. So that's how we find domain. We basically look out for 2 things, division by 0 and a negative in the radical. We can't have either of those things. And so as long as you start off by saying whatever's in the radical has to be greater than or equal to 0, and whatever's in the denominator has to not equal to 0, then you'll be easily able to find the domain of a function.
By 2. I can't do this with you 2 laughing back there.
Work it. Work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
Has to be
Less than.
yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.